In this video, let me consider one numerical on T parameters. For the network shown below, find T parameters. T parameters are also known as ABCD parameters. So this is the given network. We are supposed to find the T parameters of this network. So here we can see that all the resistors are having 3 ohm values. So this is the 2-port network. For easy simplification, I will try to convert this 3 ohm, this 3 ohm and this 3 ohm are connected in delta fashion. I will try to convert this into star fashion. So if we try to convert that into star fashion, the resultant star circuit something looks like this. So let this is R1, let this is R2 and let this is R3. So in equivalent star network, this R3 will come in series with this 3 ohm. Let's calculate the star values. That is R1 is equal to the product of adjacent resistors, that is 3 into 3, 3 into 3 divided by sum of these 3 resistors, that is 3 plus 3 plus 3, which is nothing but 9 by 9 is equal to 1 ohm. So here R2, R3 will also be having the same values. Therefore, R1 is equal to R2 is equal to R3 is equal to 1 ohm. Now let me redraw the circuit by considering star values. That is, now the circuit looks like this. So this is R1, that is 1 ohm, and here we have this R3 is in series with 3, that is 1 plus 3 is, this is 4, and here we have R2, that is also 1 ohm, this is also 1 ohm, and this is the equivalent network. So let V1 is input voltage, I1 is input current, V2 is output voltage and I2 is output current. Now for this circuit is equivalent of this circuit. Now we'll try to find the T parameters of this circuit. The T parameters are defined as V1 is equal to A V2 plus B minus I2, and I1 is equal to, we have C V2 plus D minus I2. This is the definition of ABCD parameters or T parameters. Let me call this as equation 1, this as equation 2. Now we'll solve this by using loop analysis method, so it will be very simple. Now apply KVL to this loop. Here we can see that the current through this loop is I1 and current through this loop is I2. I will apply KVL to loop I1. I can get V1 is equal to voltage across 1 ohm is 1 into I1 plus, in 4 ohm resistor both currents will flow, that is 4 in bracket I1 plus I2, or I can write V1 is equal to I1 plus 4I1 plus 4I2, or I can write V1 is equal to 5I1 plus 4I2. I will call it as equation 3. Now similarly, let me apply KVL to this loop. I can write V2 is equal to that is V2 is equal to, we have 1 I2 plus 4 I1 plus I2. Simplifying this, V2 is equal to, we'll get 4 I1 plus 5 I2. We'll call it as equation 4. So here now I will rewrite equation 4 as, that is, from equation 4 I can write 4I1 is equal to V2 minus 5I2, or I can write I1 is equal to V2 minus 5I2 divided by 4. Let me call this as equation 5. Or I can write it as I1 is equal to V2 by 4 minus 5 by 4 I2. Let me call it as equation 5. So now compare equation 5 with equation 2. So here we can see that if we compare equation 5 with equation 2, so here I1 is equal to CV2. Here we have C value will be 1 by 4. That is 1 by 4 V2. So 1 by 4 is C. I can write C is equal to 1 by 4. And here we can see plus D minus I2. That is nothing but it is plus 5 by 4 minus I2. So D value is 5 by 4. So here D is equal to 5 by 4. So now substitute the I1 value from equation 5 in equation 3. Therefore, equation 3 can be written as, so here equation 3 is V1 is equal to 5 into I1. So I1 is nothing but V2 by 4 minus 5 by 4 I2. That is V2 by 4 minus 5 by 4 I2. So here we have plus 4 I2 plus 4 I2. Simplifying this, V1 is equal to 5 by 4 V2 minus 25 by 4 I2 plus we have 4 I2. So simplifying this further, I can write V1 is equal to 5 by 4 V2 minus 25 by 4 plus 4. It gives 9 by 4, that is I2. Now call me it as equation number 6. So now compare equation 6 with equation 1. Here coefficient of V2 is 5 by 4, that is A is equal to 5 by 4, and here coefficient of coefficient of minus I2 is B. So here coefficient of minus I2 is 9 by 4. Therefore B is equal to 9 by 4. So therefore I can write the final answer as A, B, C and D matrix is equal to, that is 5 by 4, B is 9 by 4, C is 1 by 4 and D is 5 by 4. So these are the transmission parameters of the given circuit. Thank you for watching.